This conference will now be recorded.
So, very good evening, students. We will conclude this chapter, alternating current chapter today, by discussing few problems. These are all from previous year's JEE papers. The first problem we are going to solve is from 2019 JEE Mains, JEE Main 2019. Okay, let us first read the problem and then see how to solve it. So the question says that in the above circuit, that means this circuit, C is given, that is square root of 3 by divided by root 2 microfarad, and R2 is given as 20 ohm. L is given as square root of 3 divided by 10 Henry. R1 is given as 10 ohm. Now the question is current in the LR1 and in CR2 path. CR2 path, actually the currents are given as I1 and I2 as you see. Okay, so LR1 path current is I1 as you see here, and CR2 path current is I2. AC voltage source, this voltage source, the voltage varies as 200 square root of 2 sine 100 t volts. Okay, so this is the variation of the voltage. Now the question is the phase difference between the two currents I1 and I2. You have to solve this problem. So how to find out phase difference? You know, RC circuit and LR circuit, they have different phases. They are not in same phase, so you have to find out what is phase difference. Okay, if you remember, when I have RC circuit, then phase difference can be written as, let me write, phi 2 is the phase difference, phase, not phase difference, phase in case of RC2 circuit. So I'm writing 10 phi 2. So this can be written as XC by R2. Okay. Similarly, for this LR circuit, let us say the phase is phi 1 and here phase is phi 2. So 10 phi 1 can be written as XL by R1 with a minus sign. Okay, so this is the formula. Okay, this is the formula. We can use this formula to find out phi 1 and phi 2. Then if we take the difference, then we'll get the phase difference. Okay, let us go to the next page. I'll give you the informations. I'm sorry, I'll just copy a page over here since I don't have empty page here. I'll just copy a page there. Okay, so let me I'll write the informations. This is a problem, I don't know. Okay, so we had seen 10 phi 2 is XC by R2. So what is XC? We know XC means 1 over omega into C, and R2 is there. So this is the thing. And see in this, what are the informations given? See, omega is given as 100. Okay, this is 100. Okay, we know V is equal to V0 into sine omega t. So this is omega. 100 is omega. Okay, and we have C root over 3 by 2 microfarad, and R 20. R2 is 20 ohm. We'll write down the informations. So this is 100. C is square root of 3 by 2, and this is 20. We can just make it 10 like this. Okay, so what is the value we get here? Actually I have written one thing wrong. This is actually in microfarad. We can just multiply 10 to the power minus 6 over here. So let us see what we get. So see, this is, so it will be actually 10 to the power 3 by root 3. That means, it is 1000 divided by 1.372, sorry, 1. Yes, 732, kind of that. Okay, so this is the thing. So this quantity is very, very small compared to this. So this 10 pi 2 is actually considered to be very, very large quantity. So we can say phi 2 is nearly 90 degree. We are just thinking of infinite kind of that. So we are just considering this as 90 degree. So we have got phi 2. Okay, phi 2 we have got 90. Similarly, we can find out 10 phi 1 is equal to XL by R1. So what is XL? XL is omega into L divided by R1. So let us, okay, so this is 100 we know, and this is, I think, root 3 by 10 Henry only. So let us see. See, L is actually root 3 by 10 Henry. R1 is 10. Omega is again 100. Okay, so this is 10. You look, we get this. Obviously there was a minus sign over here. Okay, if there is a minus sign, what you get this to be, uh, this pi 1 to be minus, oh sorry, 120 degree. Okay, 120 degree. Okay, minus 3, that means 120. Okay, if we get that, now the phase difference delta phi, or therefore the phase difference, therefore delta phi can be written as phi 2 minus phi 1. Phi 2 minus phi 1, that is phi 2 is 120, phi 1 is 90. Oh sorry, this is phi 1 and phi 2. Let's see what we have written. Okay, phi 2 and this is phi 1. Anyway, what we have to do, we have to take the difference means I'm just taking a magnitude. Say, let us say we are taking the magnitude. Okay, difference means you have to anyway take the magnitude, so it will be 30 degree. Okay, let us see what are the options given over here. See, so option one of the option is 30 degree, that is there, and 60 degree is there, 0 degree is there, and 90 degree is there. So we have got the answer for this question. So the point is that you need to know the expression for the phase difference for LR circuit and XC circuit in this case. Okay, then other values are given already. You have to just do a most simple calculation here and find out it. Okay, now look, there is a figure over here in this problem 2. In the given circuit, excuse me. In the given circuit, source has AC source, you see here, has angular frequency omega to be 100 radian per second. Considering the inductor and capacitor to be ideal, that means they don't have their own resistance. The correct choices are the current in the circuit approximately 0.3 ampere. The current through the circuit I is approximately 0.3 into square root of 2 ampere. The voltage across 100 ohm resistor is 10 square root of 2 volt, or the voltage across 50 ohm resistor is 10 ohm. So we have to find out. See, this question, this is a question where more than one answer could be correct. More than one answer will be correct. So we have to actually see all the options whether the options are given correct or wrong. Okay, that means you have to find out the current, you have to find out the voltage across 100 ohm, and you have to find out the voltage across 50 ohm resistor as well. Then only you will be able to conclude which are the options or which is the option correct here. Okay, so how to solve this problem? So let us just break the current. It is the total current. So let me say through this the current is I1, and through this branch the current is I2. Okay. In fact, I cannot say the direction because it is the DC, but at least I can say the current through this CR branch is I1, and current through LR branch is considered. Now I have figure over here. So I have taken the current through the CR branch is I1, and current through the LR branch to be I2. Okay. Now if you want to find out current through this, how to find out that? We have to actually find out current. Before that, let us see what is XC. What is the impedance or resistance through this path and through this path? Like this will not be exactly resistance. This should be in impedance. We need to find out impedance through each branch. So first branch, XC we know 1 by omega C. So that is omega is given as 100, I hope 100 radian per second. So 100 is given. What is C? C is 10 microfarad. Oh sorry, 100 microfarad. Okay, so now look here, it is 10 to the power 4, so it will be 100 ohm. This will have unit 100 ohm. So we have got the impedance across or impedance for the path CR. Like at least we have got capacitive reactance, that is 100 ohm. Now we have resistance also here in this path, in this branch, so that is 100 ohm, right? Then what is the impedance through branch 1? So that is given by, impedance is given by x square plus r square. If we put both the values, look what you get. This is also in ohm. So this will be 100 root 2 ohm, right? Now see, we know what is the phase difference. Phi 1 could be written as 10 phi, that is xc by r. This we can write. So xc was 100, and see this will be z, I hope. This is not hope, this is z1, not r. Xc by z. So z1 is actually 10 by root 2. So this is again a ratio, and this is omega. Okay, anyway, so this will give you 1 by root 2, which is nearly equal to, so I'll get, I'm sorry, this is not tan inverse, this will be cos inverse. This should be cos inverse. Okay, I hope you are remembering the figure. Cos inverse, and this is not 4, this is z1. Okay, now once we get this, similarly for the other branch also we can do that. What is the other branch? This is the branch. So z2 we can be able to find out as omega l, omega l, that is xr, sorry x, yes, so that is xr, xl, and this is 50 square. So omega into l, what is this value? L is 50. So this is actually x is equal to omega into l. Let me just see once again. Omega value, oh, 100. All right, omega is 100, so that's fine. Okay, I'll just rewrite this. Omega is 100, right? So 100 into 50, sorry, 100. So this is okay. So this is the one. Now, if we find out 50 square, okay, just a minute. I think omega into L is actually 0.5. Oh, this is 0.5. So it will be 50 actually, 50 Henry. Sorry, omega L is ohm now. This is also 50. Omega L is also 50 and this is also 50. So you should get actually 50 square plus 50 square. That means root 2 50 square. Okay. Or if we further simplify, what we will get, it will get a very nice term to be okay. So I'm sorry, this is 50 means root 2, 50 root 2. Okay, we'll get 50 root 2. All right. So this is that Z2 also. We have got Z1 and Z2. So we have got Z1 and Z2 as I said. So Z1 is 50 root 2. Z2 is given as 50 root 2 ohm. Z1 was 100 root 2 and this is 100 root 2 and this is 50 root 2. Okay. So now if I find out current, I1 is equal to V by Z1. Okay. So V means the peak values if we take, that is 20. This value is given as 20. 20 by V1. So 2 by 5, root 2 by 5. Sorry, root 2 by 10. This will be root 2 by 10. Okay. Root 2 by 10. And then V1 or V100. V100 is V by Z1. Sorry, V100 means I into Z1. I into Z1. I1 into Z1 if we do. Voltage across 100 ohm will be, sorry, this will be I1. B100 is 100 into I1. 100 is the resistance. This is 100 into I1. I1 is again, so this is 100 into I1. Now we know what is I1. I1 is, sorry, so I1 we had got actually 2 by root 2 by root 2 by 10. This is voltage. So this is the voltage across 100 ohm. So in the options, what was given in the option? Let us look there. It was 10 root 2, but it is very yes, this is 10 root 2. Okay, then voltage is actually matching. Okay, 10 root 2. Now similarly, if we want to find out V50, that means through the other bunch, V50 ohm will be 50 into I2. I2 is 2 by 2 by 5. I hope this is okay. So I2, let me write 20, sorry, 200 by 200 by Z2, that is 50 root 2. So it will be 20 root 2, 20 root 2. Okay. I think there is a small mistake in this. Okay, let me just do this thing alone. I2 I have to calculate, right? So I2 before it is calculated, omega into L, omega is 100 into L 0.5 square plus 50 square. So it will give you actually this is 15 to root 2. Then if I want to find out, so I2 will be V by, so V is 200 divided by Z is root 2 550. Okay, anyway, so what I just tried to do is I'm just summarizing. We have first calculated what is impedance through this. I have taken two currents, right? So I1 through this, I2 through this. So that is what I had to find out. What is I2? I'm just directly writing what is I2. just let me write now I2 and V50 ohm to be I2 into 50. Okay, that means this will be again 10 root over 2 volt. Yes, because both branches will be the same, having the same. Okay, so this branch we had already found out I1 has to be I1 has to be 1 by 5 root 2, and voltage across is 100 ohm is 100 into I2. So what is that I2? I2 was root 2 by 5. So this is this 5. Okay, so finally this also will be actually 10 root 2 volt. Okay, so then you know what is the resultant I? These are actually kind of I1, I2 have mutual phase difference 90 degree. So they have 90-degree phase difference. Okay, and you know you can just take the combination of this current, not this difference, combination of this current, so that we get the original current back. So that can be written as I is equal to square root of I1 square plus I2 square. Okay, so ion square square root of ion square plus I2 square, and that would actually give you 0.34 ampere. Phase difference will be 90 degree because this is LR circuit and this is CR circuit, so phase difference will be 90 degree. Okay, degree C. All right, so this is done. We'll go to the next problem. This is another interesting problem we have to solve. So what is the problem? Let us first read the problem itself. The problem states that in the figure below, the switches S1 and S2 are closed simultaneously at t is equal to 0. So in this figure there are two switches as you see, S1 and S2, and you can see there are two LR circuit. Okay, two LR circuits, and there are two batteries V1 and V2. Let us see what is written. So the question is that if the both the switches are closed simultaneously at t is equal to 0, and a current starts to flow in the circuit, both the batteries have same magnitude of electromotive force. Both are having same electromotive force. Okay, the polarities are as indicated in the figure. This is positive, this is negative, whereas this is negative, this is positive. Okay, and ignore the mutual inductance between the inductor, this and this. The current I in the middle wire, this is the middle wire, the current I reaches its maximum magnitude I max at t is equal to tau. Which of the following statement is true? I am writing the statement, just see. Statement 1 is that A statement A is Imax is equal to V by 2R. First. Second option is Imax is equal to V by 4R. V by 4R. C. Tau is equal to R, sorry, L by R, ln tau is equal to L by R ln 2 and option D says tau is equal to 2 L by R ln 2. So which among four options are correct? So that we have to find out. So let us solve the problem. So how to solve this problem? See, in an inductive, since there are tau and all those things and currents, etc. So if we consider two loops here, okay, two loops, and you can see these are actually these are DC batteries. So we can actually go with uh, Kirchhoff's law, thinking this as loop 1 and flowing the current through this circuit. This loop is I1, and since the battery is this way, positive terminal, let us say the current I2 is flowing in this loop 2. So this is L1 loop and this is loop 2. This is what we are considering. I'll just do the solution here. So what we have considered, this is I1 flowing and this is I2 flowing. Okay, so I1 has basically this direction, I2 has this direction. Okay, so if we can find out from this what is I1 and I2 somehow, then it will be easy to find out the answer. Okay, look, whatever it is, if I say this is I1 in LR circuit, how it would be? It would be actually V by R, that is the I0, whole into 1 minus, this is charging circuit. Okay, this charging when it is suddenly switched on, both of them are switched on. So this will be actually then minus e to the power, so e to the power t divided by L by R. L by R, this term is actually time constant. Okay, So similarly, this is, see, in this there is L, and here there is L2, sorry, 2L. So we can write both the current in a similar way, tau by 2L by R. Okay, V by R. So this is the way I can write the current. And you see, according to this polarity, I will be actually superposition principle. From the superposition principle, I1, or sorry, I2 minus I1 I have to write, because the current is this way. So I1 minus I2. I was right in the beginning. So I1 minus I2. I2 is going in the opposite direction. So I1 minus I2 will give you the current through this middle wire. So if I just put the values, minus of V by R, TR by 2L. Okay, so the first terms will be getting cancelled. So it will actually be V by R, V by R, and this will be positive, e to the power minus TR by 2L minus e to the power minus TR by L. So this will be the thing. Now what we can do is V by R e to the power minus E TR by 2L. Let us take this as common. So we'll get e to the power minus T by R, sorry, T into R by 2L. This one we'll get. Okay. So once we get this, what we can do for maximizing, so we know, so the answer, the question was when it will be maximum. Okay, so there are two things, maximum, and this also is that. So in this circuit, what will be the time constant and what will be the maximum value of that? So for Imax, we can write di dt to be 0. So if you just do this derivative, time derivative, and make it 0, look what we'll get. So from this, if you just do it, uh, from this itself you can just try to do. So V by R, and the minus to the power R by 2L, and this will be minus V by R, V by R, this is, I think, yes, 2L, and this is V by R, minus will be plus, and this will be R by L. Okay, and along with that, here there will be e to the power minus RT by 2L, and here it will be e to the power minus RT by L. This would be 0. So these are constant. You look here, this R goes with this R goes with this. So V by 2L, in one case there will be V by 2L, and this will be V by L. So okay, so the minus sign, if we take this way, so V by 2L, e to the power minus TR by 2L 1, and another one will be V by L, e to the power minus TR by L. So look, this two guys will go away, V by L, V by L. So if I write it, okay, I have another page anyway. So V by L, V by L goes up. This will be e to the power minus T R by 2L is equal to e to the power minus T R by L. Okay. So if we just take this way, look what we get. half or e to the power, so e to the power minus tr by 2l, and this is divide means it will go divide. If you divide here, it will be getting minus of this, so plus tr by l. This will be 2, say. Okay, so if you just solve it, e to the power, it will be e to the power minus tr by 2l is equal to, sorry, it will be plus, then it will be plus is equal to 2. Okay, or see, if we just make it ln both side, ln2 is equal to then tr by 2l, right? Tr by 2l. So from here, what will be t? The time will be 2l by r ln 2. Okay, so this was the thing. So I have got t. Then what will be imax? Imax will be, then see, if we put this value, we had there I, we had, right? We had I to be v by v by r v by r e to the power minus t into r, t into r by l, sorry, 2l minus e to the power tr by l. It was like this. So if we put this value t, then we will actually get v by 4r. Okay, if we put the values of at t is equal to 2l by r into ln2, if we put that, so we'll get v by 4r. So maximum value will be v by 4r. So we have here actually two options to be correct. You can see that the time constant, the options were this time constant, so this option is true, and the imax is true. Okay, imax is true, we can see that. Okay, and we have another option true, that is the tau, time constant, to be 2l by r ln 2. So this option also is correct. We have done that. Okay, so this is how you have to solve this problem. We have another last problem which we will be solving, and then we'll stop the problem. So we'll stop the class after solving this. There are so a current carrying infinitely long wire is kept along the diameter of a circular wire loop without touching it. The correct statement. So what are the correct statement? So first option is the EMF induced in the loop is zero if the current is constant. The EMF induced is zero if the current is constant. Current is constant. First option. A current carrying infinitely long wire is kept along the diameter of a circular loop, wire loop, without touching it. Then B, the induced EMF in the loop is finite if the current is constant. The induced EMF in the loop is finite if the current is constant. Current is constant. Then option 3 is that EMF, the EMF induced in the loop is zero if the current decreases at a steady rate. The induced EMF in the loop is zero. Loop is zero if the current decreases at a definite rate. At a definite rate. Okay. Then option 4, the EMF induced in the loop is finite. The EMF induced in the loop is finite if the current decreases at steady rate. Here definite, not definite, it is steady rate. Steady rate. This is zero, it says, and this shows if the current decreases at a steady rate. Okay, so these are 4 options. We have to find out what is the correct answer for this. So actually there is a straight current carrying in infinite wire. It will actually produce magnetic field. Okay, you look here, if you have a straight wire and you have a loop over here, so it will produce magnetic field in this way, like this. It is going into the page, and here it will be coming out of the page, right? But the flux will be zero if the current is steady. Okay, in any case, actually, see, the current is steady, then the flux is not changing anyway, that is fine. But in this case, you look, the half of the loop is having flux downwards. Okay, half of the loop having flux upward. So in any case, the flux will be, net flux will be zero in this case. In any case, net flux will be zero. So if the net flux is zero, then induced EMF in all condition will be zero in the circular loop. Okay, so in any case, the induced EMF is zero in any case. That means all of the options are actually, see, the zero, where everywhere where there is zero, induced EMF will be zero. So this 3, I'm sorry, this is not that. So A and C will be true. In any case, it will be zero, whether the current is steadily decreasing, or the current is constant, or current is whatever may be the condition. You can see that the flux lines in one, like half of the loop, the flux lines are in the downward, and in the other half of the loop, the flux lines are in the upward direction. That means the net flux will be zero in any case. Okay, therefore the induced EMF will be zero in all conditions. So with this, we'll stop it here. We'll have next class on electromagnetic wave. So thank you for your patience. Bye for today.